Good morning friends. In the previous video we discussed about the very first chapter of this book, that was the number systems, right? Now we are going to continue with the next topic of this book, that is chapter number 2, the polynomials. So in brief, let me brief you about this topic, the polynomials. Polynomials are nothing but those mathematical expressions which can be expressed as a sum of several terms of different variables but of same variables but of different powers. Then in this chapter we are going to study about the zeros of a polynomial, how to find out the zeros of a polynomial. Then we are going to also discuss about some algebraic identities, right, that you have already studied in the previous years, and we are going to just continue with those identities. We are going to also we are going to also discuss about how the polynomials are expressed, how can you find out the coefficient of the variables, how can you find out different variables, what are the constants, and so on. So in general, today we are going to discuss about the topic polynomials. Starting with the definition of the polynomials. Polynomials are nothing but the expression, right? Define polynomial. If it is asked how to define the polynomial, then it is nothing but an expression of more than two terms. It is an expression of more than two terms expressed as the sum of those algebraic terms as expressed as the sum of those algebraic terms, not as of same variable, or you may call it as a different variable but of different powers. As the definition goes, that it is an expression of more than two terms expressed as the sum of those algebraic terms of same variable but different powers. Same variable, friends, and the powers must be different. The powers also called it as the exponents. These exponents we were discussing in the previous chapter number 1, right? So that is how a polynomial is defined. Now, as I have said here, that it is the sum of those algebraic terms of same variable. Let me say, for example, in this polynomials, in the examples of polynomials or the definition of polynomials, as it is said of the same variable. So first of all, let me discuss that what the variables are being taken in general, right? In general, whenever you select a variable, you will always select it from those of x, y, z, w, u, v, and so on, right? These are the general examples of the variables. You may also include them in t, then p, then and so on. But whenever we are talking about the powers, these powers are always the real numbers, or you may call it as the whole numbers. Real numbers includes everything, but these whole numbers are of a specific type. So rather than calling these as real numbers, we may call them as the whole numbers. So the powers here, the exponents of the variables present here, will be from the classification of the whole numbers. As we discussed in chapter number 1, whole number includes the perfect integers starting from 0 to infinite, rather than neglecting the negative numbers or the negative integers, right? So this is about the definition of the polynomials. Again, let me discuss an expression of more than two terms expressed as the sum of those algebraic terms of same variable but of different powers. Here the variables can be taken from this group x, y, z, u, v, w, t, p and so on. Then the whole numbers, that means the different powers, the powers that we were talking about will be from the category of the whole numbers. Okay friends, so that's it about the definition of the polynomials. You just need to remember this. Let me show you how the polynomial can be written. For example, if I say that is 2x, friends, you might come to a conclusion here that, sir, this 2x is only a one term, but how it is made a term? So this 2x, or if I write it down as 2x, 1 upon 2x, 3x and so on, then let me write for another variable also, 5y, 70 and so on. These are all the examples of the polynomials. But right now in these examples we are only having a single term present. This whole thing, 2x, 3x, 5y, 70, 1 upon 2x, these are known as the terms. T-E-R-M-S, terms, right? And term is nothing but the product of a constant and a variable. Term is nothing but the product of a constant and a variable. That means whenever a constant is multiplied with any variable, then that combined product is called as a term, right? Is called as a term. These constant here, again, this will be from the category of whole numbers, and the variables that we have discussed here, that will be same, right? The variables that we have discussed here, that will be same here. Constant that we have discussed here will again be a whole number. So in other words, you can also call it as a polynomial is the sum of the algebraic terms. Directly you can call it as a polynomial is the sum of the algebraic terms. See friends, I have again mentioned here the word terms, right? So this is how a term forms. You can now call this 2x as a term, 3x is a term, 5y is a term, 70 is a term, and 1 upon 2x is also a term, right? So these are all the terms. Now whenever these kind of terms are being added, this is simple. 2x, this is a term right now, 3x, 5, these all are the terms, right? Now whenever these kind of terms are added, but the condition being of different powers, let me say now, for example, if I write down some of the terms here, 2x, 3x square plus 4x, 9x cube plus 7, 7x square plus 3x plus 1 and so on. So whenever these terms, you can call now these as terms. This 2x is a term, 3x square is a term, 4x is a term, 9x cube is a term, 7 is a term, 7x square, 3x plus 1, these all are individual terms. But rather than writing them individually, what I have done some groups, means I have simply added them. That means this 2x, this combined 3x plus 4x, this 9x cube plus 7, 7x square plus 3x plus 1. I have added these all terms, some in groups and some in different manner. Okay, so whenever these are added, that means this whole combined addition has now become a polynomial. polynomial. So the definition of the polynomial: an expression of more than two terms such that or that it is expressed as a sum of these algebraic terms of same variable but of different powers. Same variable, see friends, the variables x and x are both same in both the terms. It is also expressed as a sum, that means it is addition here. It is being added, 3x square is added to 4x, right? So these variables are same, powers are different, and again they are added. So now this combined 3x square plus 4x can be expressed as a polynomial. Here 9x cube plus 7 is also a polynomial. The next thing, 7x square plus 3x plus 1 is again a polynomial. So in this way you can write down different examples of polynomials. Now again, what if I am asked to find out the polynomial in which variable it is given? So friends, here these polynomials are all expressed in the variable y, right? See, 2x is associated with the variable x. This polynomial is associated with the variable x. This is also with x, and the last one is also with x. So these are all the polynomials in variable x, right? These are all the polynomials in variable x, right? So for example, if I have taken these 3x square plus 4x as a polynomial, then this polynomial is expressed in terms of variable x. Is it clear, friends? So this is how a polynomial is defined. So these are all the polynomials in variable x, or for example, polynomials in one variable. In this chapter we are going only to discuss about the polynomials in one variable. We are not having any polynomials with two variables or three variables associated with the same polynomial. Is it clear, friends? So these are all the polynomials. Let me say, for example, if I am given another example here, 3t plus 4, then 5y square plus 4y plus 3, then 9z square plus 4z. These are the examples given to me. So this 3t plus 4 is a polynomial, yes or no? Yes, it is a polynomial. Again, is it a polynomial in one variable? Yes, only I can see the t here. There is no another variable defined. So this is a polynomial in the variable t. So yes, this is a polynomial in variable t, right? Similarly for the second one, this is a polynomial in variable y, and the third one is a polynomial in variable z, right? So these are the examples of different polynomials that we have discussed till now. Okay, so that is about the polynomials in one variable, how the polynomials are being formed, and some of the examples of polynomials in one variable, right? Now, as we discussed here, what the powers of the polynomial, the exponents of the variables present in these polynomials will be from the whole numbers, right? The constants that are associated with the variables, will again be the whole numbers, and these constants are known as the coefficient of the variables. So the numbers, let me define it here. Coefficients. The number multiplied with the variable in a polynomial is called the coefficient of that variable. Right? It is known as the coefficient of that variable. For example, if I have, for example, 4x square plus 3x plus 2. So in this example, the coefficient of x square, that is 4, because see friends, in the term 4x square, the number multiplied with the variable x, but here the variable is not only x, the variable present here is x square. So friends, the number multiplied with the variable x square is 4, or the number associated with the variable x square is 4, so that is 4x square. Similarly, coefficient of x, that is 3, and the constant term, is 2. Now friends, you might come to a doubt here that, sir, what is the constant term? The constant term is a term, or the term free from the variable in a polynomial is called the constant term. Right? The term free from the variable in a polynomial is known as the constant term. Friends, free from the variable, that means there is no variable seen with that constant, that number. There is no variable seen. Actually the variable is present there, but we cannot see it physically. Like we can see here 4x square, that means x square is present here. 3x, that means x is present over there. But can you see any variable with the term 2? No. But then also we call it as a term. That means there is a variable present here, but that we cannot see. That is a invisible variable over there. So this 2 can be written as x raised to 0. And as we know that x raised to 0, or number having its exponent or power 0 is equals to 1. Any number having its exponent or power as 0 is equals to 1. So that is 2 into 1, and which is equals to 2. So physically there is no variable present, but mentally it is present. That is the magic of the constant term, right? So the constant term is the term present in a polynomial free from the variable, is known as the constant term. So this is how the variable is being defined. What are the coefficients, the number associated or the number multiplied with the variable present in the polynomial are or is called the coefficient of that variable, right? So these are the terminologies that you need to understand. The very first thing, definition of a polynomial. Second one, how to identify a polynomial in one variable. The third one, that is the coefficients. And the fourth one, that what are the terms of the variable. How can you define the terms of a variable? Is it clear, friends? Now, nextly, we are going to discuss about, once we have studied about the polynomials, let us discuss about how a polynomial is written, is denoted. Because, see friends, in this universe or on this planet, in this country India, each and every person has an identity, right? My name is Naitik, your name might be something, somewhere, or something else, right? Whatever the name you may, that means each and every person has an unique identity, that is its or his or her name, right? Similarly, a polynomial also has a name. That means a polynomial, if I want to define a polynomial, if I want to say that this is a polynomial, then how can I define? I cannot simply write down the whole polynomial and say that this is a polynomial here, right? So denoting a polynomial, denoting a polynomial. A polynomial is defined always, a polynomial is defined, or it is always denoted as, it is always denoted as p of x, q of x, g of y, r of s or r of z, or anything you can write it like p, q, g, r, or similarly you can write down many more examples if you want to write down, but mainly when we write down a polynomial, we only write down in the form of p of x, q of x or g of x, and sometimes in the form of r of x, right? This alphabets written inside the bracket, the alphabets that are written inside the bracket, let me write down again, if you, it might not be visible to you, then p of x, g of x, q of y, r of z, and so on, like this. The variables, the alphabets that are being written inside the brackets are the variables of the polynomial, right? So what does this simply means? P of x, p of x, that simply means it is a polynomial in variable x. P of x simply means it is a polynomial in variable x. This g of x simply means this is a polynomial in variable x. This q of y simply means this is a polynomial in variable y, right? Q of y means variable in, polynomial in variable y, and r of z means polynomial in variable z. It is a polynomial in variable z, right? So in this way a polynomial can be denoted. A polynomial simply means it is a mathematical expression expressed as an algebraic addition of more than two terms of the same variable but of different powers. It is being denoted as p of x, g of x, q of y, r of z, and so on. That means the variable, the polynomial that we have defined, the variable that are present in the polynomial will always be written inside the brackets, and outside the brackets these are the names p, q, g, r. These are all the names. You might select any one of them from the given names here, the denotions here. Then we have discussed about the terms. Terms are simply the product of a constant number with the given variable. Those are known as the terms. Terms of a polynomial, that also we have discussed. And finally we discussed about the coefficients of the variables present in the polynomial, right? So the coefficients of the present, that means the number associated or multiplied with the variable present in that polynomial are known as, or is called, the coefficient of that variable, right? Now moving further with this, we are going to discuss about the degree of a polynomial. Friends, this is very important, how to find out the degree of a polynomial. Sometimes there might be questions asked in the examination finding out the degree of the given polynomial. How to find out the degree, what the degree of a polynomial will be, and so on. Mainly this question is always asked in 1 marks, right? So it is quite an important topic, very smaller one, easier one to understand this, that what is the degree of a polynomial. Sorry friends. Okay, let us continue with this. The next topic, that is the degree of a polynomial. Degree of a polynomial. Degree simply means the order. Sometimes it is not the order of the polynomial, but how we can define this degree, and based on this degree of the polynomials, next we are going to study about the classification. Now, degree of the polynomials, it is defined as the highest power of the variable present in the polynomial is the degree of that polynomial. The highest power of the variable present in the polynomial is the degree of that polynomial, right? The highest power of the variable. Let me take for example p of x. Note that friends, see, now I am writing it perfectly. P of x, this is the name of the polynomial. P of x is equals to 4x square plus 5x plus 7. So how many terms are there here in this polynomial? 3 terms. The first one is 4x square, the second one is 5x, and the third one is 7. Now look for the highest power of the variables present here. The highest power, you can see powers, that means exponents, and exponents are always written in the raised to form of a variable. Raised to form, that means the numbers that are being written in the exponents of a variable, these are known as the powers of the variable. So friends, note for the highest power present here. The highest power here is 2, as you can see, right? That means the degree is equals to 2, or the degree of this polynomial is equals to 2. Okay, so I am having some more examples here with me. Let us quickly see the degrees of these polynomials, and then we shall move further. P of x, that is x raised to 5 minus x raised to 4 plus 3. The third one is q of y is equals to 2 minus y square minus y cube plus 2y raised to 8. The fourth one I am having is P of x is equals to x plus x square plus pi. The fifth one I am having g of x is equals to 2. The sixth one I am having is q of x is equals to root 2 plus x minus x square. And finally the seventh one is r of y is equals to y raised to 4 plus y plus 5, right? So these are some 6 examples here with me. The first we have already discussed, and the next we are going to discuss it right now with us. Here in the second example, the degree of the polynomial present here in this variable is what? So first of all, we shall look for the terms present here. There are only 3 terms present, and there in these terms the highest power here is 5. So the degree is equals to 5, right? In the third one, let us see. The present terms here are 2 minus y square minus y cube plus 2y raised to 8, right? So in these present terms the highest power is 8, so the degree is equals to 8, right? Friends, note that we are only looking for the terms present in the polynomial. We are not going to look for the terms absent in the polynomial, because that is of no use here. Here there are terms missing, y raised to 4, y raised to 5, y raised to 6 and y raised to 7. These are all the terms missing, but we are not going to look at those terms. We are only going to look at those terms in which the highest power exists and also that term with the highest power is present in the variable. So the fourth one given here is p of x equals to x plus x square plus pi. Note that, friends, pi is a constant value. The value of pi is not going to change anywhere. So this is a constant value, and hence we can say that x plus x square plus pi is a polynomial here, and the degree, the highest value is 2. That means the degree is also 2, right? In the next one, it is said that g of x is equals to 2. There is only a constant term present here. So if there is a constant term present here, then what did I say? That the constant term is written like this 2, but again there is a variable associated with this constant term, or that number having a variable with a 0 power, right? A 0 power, that means 2x raised to 0. It is written like 2x raised to 0. Therefore, what you can say now? This 2 can be written as 2x raised to 0, and hence here the degree is 0. This is a special case. Let us first discuss the degree of the remaining 2, then we shall come again back to this degree 0. Again here, root 2 plus x minus x square. So root 2 is again a constant value. The value of root 2 is not going to change. So root 2 plus x minus x square. Hence the degree here is equals to 2, right? And lastly, it is r of y equals to y raised to 4 plus y plus 5. So the highest power associated with this variables here is 4, and hence the degree is equals to 4. Okay, friends? So till now we discussed about these degrees, but I have marked a question here with degree 0. Note that, friends, whenever there is a degree 0 of any polynomial, then that polynomial is known as the 0 or constant polynomial. This is known as a constant polynomial. As the name suggests, constant polynomial, there will be only a constant term, a constant value present in that polynomial only. Only and only a constant value. That means none of the values or none of the terms present in a constant or a 0 polynomial will contain any variable. Right? None of the terms will contain any variable. So that is known as a constant polynomial or 0 polynomial by the condition that it has a degree 0. So if it has a degree 0, then it is known as a 0 polynomial. Or if you say that, sir, it does not has a degree 0, but it only has a constant term present, then it is known as a constant polynomial. So in this way you can define the constant or a 0 polynomial. Now coming back to the next topic, that is the classification of the polynomials. Okay, now we are going to discuss about the classification of the polynomials. the classification of polynomials. Friends, broadly the classification of polynomials, when the mathematician may have classified, that was based on the number of terms present in the polynomial. And lately, when the topic came of the degree of polynomials, the classification was again made on the basis of the degree of the polynomials. So we are going to discuss both, and we are going to see that how both of them is made. The first one is classification based on the number of terms present in the polynomial, and the second one is based on the degree of the polynomial. The second one is based on the degree of the polynomial, right? It is based on the degree of the polynomial, and it is based on the number of terms present in the polynomial. So friends, let us first of all discuss about the number of terms present in the polynomial. In this category, we are having some 3 or 4 the first one, that is a monomial. The second one, that is a binomial, and the third one, that is a trinomial. If it is not visible, I am going to write it down again here, that it is a monomial, the first one, the second one, that is a binomial, and the third one is a trinomial, and later on it is written as the polynomial, right? And lastly, that is written as polynomial. Let me write it down here itself. We are going to discuss the classification of the polynomials, and again there is a polynomial present here in this classification. So monomial, that means there is only one term present in the polynomial. Monomial, that means only and only one term present in this polynomial, that is known as a monomial. Binomial, that means only 2 terms present here, and trinomial, that means only 3 terms, right? As the name suggests, mono, that means 1, bi, that means 2, tri, that means 3, and poly, that means infinite, right? Mono, that means 1, bi, that means 2, tri, that means 3, and poly, that means infinite, right? So monomial, that means the polynomial containing only and only one term. Binomial, that means a polynomial containing only 2 terms. Trinomial, that means a polynomial containing 3 terms. And polynomial, that means an expression. Polynomial, that means an expression containing more than 3 terms. It is discussed, or it is classified as a polynomial. Friends, in the definition of the polynomials, we said that it is expressed as an algebraic sum of 2 or more than 2 terms. So that is limited here in the classification, because we are having that if it is expressed as a sum of 3 terms, then that is known as a trinomial. Okay friends, now let me write down one examples of each of this. Only one term, that means p of x is equals to 2x, right? Only 2 terms, that means p of x is equals to 4x square plus 4, or 4x plus 4. Let me write down 3x plus 4. right? Then for the third classification, that is p of x is equals to 3x square plus 4x plus 5, and we know that a polynomial can be written like it is an algebraic sum of more than 3 terms in the equation or in the polynomial, right? That is a polynomial. Okay, now the next classification is the classification based on the degree of the polynomial. So friends, in the previous topic we already discussed about the degree of a polynomial, right? So what is the degree of a polynomial? The degree of a polynomial simply means the highest power present in the variable is known as the degree of a polynomial. Okay, so based on the degree of the polynomial we are having again some classification here, that is, okay, let me draw a line over here. The first one, that is a zero polynomial, or again a constant polynomial. Then the second one, that is the linear polynomial. The third one, that is the quadratic polynomial, and the fourth one, that is the cubic polynomial. So zero or a constant polynomial, linear polynomial, quadratic polynomial, cubic polynomial, these are the examples, sorry, my mistake, these are the classification of the polynomials based on the degree. These are based on the degree and these are based on the number of terms present here in the polynomial. Okay friends, so based on the degree of the polynomials we are having zero, constant, zero or constant, linear, quadratic and cubic. Now let us discuss what are these. A polynomial with a degree 0, if the degree of the polynomial is 0, then that is known as a zero polynomial, or it is also known as the constant polynomial, right? That polynomial with a degree 0 is known as a zero or a constant polynomial. Then the second one, linear polynomial, is a polynomial of degree 1. If the degree of the polynomial is 1, then that is known as a linear polynomial. Then the third one, that is the quadratic polynomial. So if the degree of the polynomial is 2, then that is known as a quadratic polynomial. And the last one, that is the cubic polynomial, that means if the degree of a polynomial is 3, then that is known as a cubic polynomial. So as the name suggests, 0, that means degree 0, linear, that means degree 1, quadratic, that means degree 2, and cubic, that means degree 3. That means these are the classification. The first one is a zero polynomial or a constant polynomial. The second one is a linear polynomial. The third one is a quadratic polynomial, and the fourth one is a cubic polynomial. So these are the classification of the polynomials based on the degree of the polynomial. Let me write down one examples of each of these. So that gives me a degree 0, that means p of x is equals to 4. Right, that is a constant polynomial or a zero polynomial. Then for the next one, p of x is equals to 3x plus 4. This is a linear polynomial. You can check it out, that the degree or the highest power of the variable present in this polynomial is 1. Degree 2, that means p of x is equals to 3x square plus 4x plus 5, right? Note that the highest power of the variable present in this polynomial is 2 and of degree 3, that means p of x is equals to 3x cube plus 4x square plus 5x plus 6, right? So that is a cubic polynomial. Note that, friends, these examples that I have written here are the random examples, so you are not going to solve this anywhere in future, right? So first, finding out degree 0, that is 4, degree 1, that is 3x plus 4, degree 2, that is 3x square plus 4x plus 5, and of degree 3, that means 3x cube plus 4x square plus 5x plus 6. So these are the classification based on the degree, and these are the classification based on the number of terms present in the polynomial, right? So this is about the brief classification of the polynomials. Is it clear, friends? So please, I request you to note it down. Okay, friends, now once we have completed the classification of the polynomials, right? Okay, let us quickly remind you that what we have studied till now. The first thing was the definition of the polynomials. Then we have studied the coefficients, the number of terms present, how a term is formed. Then we have also studied about the classification of the polynomials, how to find out the degree of the polynomials. Now we shall study about how to identify a polynomial. Identifying a polynomial, it is very simple, right? You just need to look at the powers of the variable present in the polynomial. So identifying a polynomial, right? Friends, how to identify a polynomial? The basic criteria here is, first of all, it must have a degree from the classification of the whole numbers, right? It must have a degree from the classification of the whole numbers. And again, you might check for the powers of the variables present, that must also be from the classification of the whole number. So let me say, for example, if I am writing 1 here, that is 4, denoting p of x is equals to 4x square plus 3x plus 2. So what can you say here? The degree of this polynomial is 2. Yes or no? Yes, the degree of this polynomial is 2. Also, if I say here that the degree is 2, then what? It is a polynomial. Okay, let me write down another example also. P of x is equals to root x plus x square plus 1. Again, you might say, sir, that the variable present here are root x and x square. So if I convert this in the form of the exponents, then that is x raised to 1 by 2 plus x square plus 1. Yes or no? Okay, so it is a polynomial because the highest power of the variable present is 2 here, right? But see, friends, I have not written the degree 2 because the logic goes here is the powers of the variables present in the polynomials must be a whole number. In this first equation, in this first example, the powers here was 2, here it was 1, and here it is 0. That means the powers were 2, 1 and 0. The highest of these three is 2, and hence the degree is 2. But here in this equation, in this polynomial, the power here is 1 by 2, here it is 2, and here it is 0. These both are whole numbers, but this 1 by 2 is not a whole number, and hence you can say that this is not a polynomial in x, because the variable has a power which does not belong to the category of whole numbers. Is it clear? So friends, you might come to a conclusion that whenever there is a variable with, the power other than the whole number, then that will not go in the category of a polynomial, or that does not satisfy the condition of a polynomial. But there might be some equations, or there might be some examples, like if I write down here the third example, that is p of y is equals to root 2 y square plus y plus 1. Note that friends, in this example there is a square root only associated with 2, it is not associated with y. That means the y, or the variable present, has a power of a whole number, or a power that is a whole number, right? Here it is root 2, that means this root 2 is the coefficient of y square, right? Root 2 is the coefficient of y square, so that is possible. But in the second example, this square root is associated with the variable x, so that is not possible. So yes, this is a polynomial of degree 2. Let me write down another example. P of x is equals to x cube plus root 3x square plus x plus 1 plus square root of x, right? So is it possible, friends? Now you might say that yes, it is possible, but see, here there are two square roots. The first one is associated with only 3, and the second one is associated with a variable x. So here the power is 3, here the power is 2, here it is 1, here it is 0, and here it is 1 by 2, which is not possible. The power of a variable present in the polynomial must be a whole number. That means here it is not a whole number, and hence you can say that that is not possible, right? So this is how you are going to identify a polynomial, whether they may be or they may be not. Sometimes the question that is asked in the examination is quite a confusing one. How? That find out the degree of the given polynomial, and sometimes they might give you an example from these kind of polynomials where you cannot get the valid degree, right? These polynomials are actually not the examples of the perfect polynomials, and hence you cannot find out any degree. So if it is asked to find out the degree of this polynomial, then you might say that the degree of this polynomial is not found, or you cannot find out the degree of this polynomial. Okay friends, okay, so I'm erasing this one and I shall write down some examples here so that you can again practice it by yourself. We shall discuss the answers here itself, right? So I'm writing the questions, you might write down the answers with me itself, and then we shall further move on to the next topic. Now we shall do some practice here rather than moving on to the next topic. So identifying the polynomial, or which of the following, the question that may be asked here as which of the following is a polynomial in one variable, right? The first one is p of x equals to 4x square minus 3x plus 7. The second one is g of y is equals to y square plus root 2. The third one is r of t is equals to 3 root t plus t root 2. The fourth one is p of y is equals to y plus 2 by y. And fifth one is g, or I'm not going to write down anything because x raised to 10 plus y raised to 13 plus t raised to 50, right? So these are some 5 examples that I have written over here. You can get some many more out of these or of the same kind from the textbook, from the exemplar, or from any of the sources that are available to you. Okay, so which of the following is a polynomial in one variable? The first one, is it a polynomial in one variable? Right, so what we are going to look at first of all is the degree of this given polynomial a whole number or not. So if this polynomial contains any of the variable that has a degree other than a whole number, then that will not be a polynomial. So first of all, here it is 2, here it is 1, and here it is 0. So yes, it is a polynomial. It is a polynomial of degree 2, right? It is a polynomial of degree 2. Or you can simply, if it is asked to write down yes or no, then you can also write that yes, it is a polynomial. So I am writing it yes, right? Then second one, is it a polynomial? Again, you can see here that I have written only root 2. I did not write any variable present in the polynomial inside the square root. So obviously these y square, or this equation, this polynomial has a degree or a valid degree. So yes, again the second one is also a polynomial. It is a polynomial of degree 2, right? Okay, third one, here there are two terms. The first one is 3 root t plus t root 2. The second term t root 2 is valid for me. Why? Because the variable present is outside the square root. So what can I write about this? This I can write it as 3t raised to 1 by 2 plus root 2 into t. Yes or no? I can write it like this, 3t raised to 1 by 2 plus root 2 into t. So that is a valid polynomial or not, friends? What did I say? That the powers of the variables present in the polynomials must be a whole number, and this is not a whole number. So no, this is not a polynomial, right? The fourth one, again you can see that if I simplify this, that will be y plus 2y raised to minus 1, because this is y here in the denominator, and that denominator when converted to the numerator will become the power of minus 1, as we have discussed in the last topic, laws of exponents of chapter number 1, right? That any variable in the denominator when converted to the numerator or when shifted to the numerator will become its powers as a negative, or that power will contain a negative sign when it is shifted to the numerator, right? So that is y plus 2y raised to minus 1. Here this y is valid, but this y raised to minus 1 is not valid. Why? Because minus 1 does not belong to the category of whole numbers, and hence you can say that no, this is not a polynomial, right? These four were all the variables in one variable only, as they were in one variable, but we have also discussed with these. See this, friends, this is a variable, sorry, polynomial in one variable. This is a polynomial in one variable. This is also a polynomial in one variable. This is also a polynomial in one variable. But with this we also discussed that whether they are valid or not. Which of the following is a polynomial in one variable, and check its validity. Validity, that means is it valid or not. So the first and second are yes, the third one are no, right? And the fifth one, See friends, here there are three terms present here, and all the three terms are having three different variables. The first one is x raised to 10, the second one is y raised to 13, and the third one is t raised to 50. So according to the given question, no, this is not a polynomial in one variable, right? So we cannot define the third one as a polynomial in one variable. But if I want to define the degree, then is it possible? No friends, the degree of this polynomial is also not possible, because we can find out the degree of the polynomial when there is only and only one variable present in the polynomial, right? Because why it is only one variable? Because what we are looking for is the highest power of the variable present. Now look here friends, there are three variable present here in this polynomial, but we cannot say that the highest power of the variable is 50 here, which is associated with the variable t. Then what about x and y? We don't know about x and y, right? There might be some term present here with the highest power of x, that is x raised to 51. It may be possible, sometimes it may not be possible. So we cannot define the degree of such polynomials where we are having more than one variables. So in both the cases, that means whether it is a polynomial in one variable, no, and check its validity. That means again this polynomial is not valid, because we cannot find out the degree of this polynomial. It may be valid in the future purpose or in the future thing, but it is not valid right now at this moment for us. Is it clear friends? So that is about the polynomial and identifying a polynomial.